Hi, welcome back. I'm Mr. Peck here. So today we are going to learn more about forces. Here's the second questions. A boy starting from rest slides down an inclined plane and reaches the bottom of the plane with velocity of 40 km per hour. If the elevation of the plane is 40 degree and the coefficient of friction is 0.1, what is the length of the plane? Okay, so here it has an inclined plane. Okay, I have drawn out the situation. We must always, for chapter 4 forces, we must always start off with a free body diagram. Alright, I want to emphasize this. When we do questions about in forces, we must draw a free body diagram and show all the forces acting on the object. Okay, and the object we denote as only one point mass, only one point. And all the forces must originate from that one point only. Yeah, all the forces originate from one point. Yeah, like you see, this object, it is on an inclined plane. So of course, the forces acting on the object is the normal force because in contact with the surface. The normal force is perpendicular to the surface. The boy is sliding down the plane, sliding down. So the motion is going down. So the friction is opposite the motion. Friction is opposite the motion. So friction is going up. Sliding down, object sliding down, friction going up. Opposite the motion. Okay, friction going up. And then it has the weight directly downward. Directly downward because of gravity. Okay, mg. So draw the free body diagram first. Yeah. So information given here, he says the plane has coefficient of friction. Coefficient, this is coefficient. Okay, let us write it down. This is coefficient. So this is the mu k, not the friction, but the coefficient. Yeah, coefficient has no unit. So 0.1. And then he say he start from rest. He start from rest. So this is the initial velocity, 0. Okay, slides down the plane, reaches the bottom with velocity. So this velocity is the final. This is the final velocity v, but in kilometer per hour. So we have to change. When we see non-SI unit, we must change to SI unit. I already changed here. The mu, okay, and the final velocity 40 km per hour. I change to meter per second. How to change? Kilo is exponent 3. 1 hour is 3,600 seconds. So divide, I got 11.11 meter per second. So final velocity already in SI unit. Must change to SI unit. So the plane is not smooth. It has friction. It's not smooth. So it has friction. Yeah, friction. What is the length of the plane? So it asks for the length. So the length, as if we look closely, the length of the plane actually is the displacement of the boy. The displacement itself is the displacement. If you get the displacement, means we get the length of the plane, isn't it? So we need to find the displacement of the boy. So information we already have is we have the initial velocity starting from rest, initial velocity 0, final velocity at the bottom v, and we want to find the displacement. But we don't have the acceleration. So in order to find the displacement, we need to find the acceleration first. Okay, it's like VUAS, VUAS. Later we use the formula VUAS. But to find the displacement, which is the length of the plane, we need to find the acceleration. Once we got the acceleration, we can get the displacement. So since this object has acceleration, so this one is about the Newton's second law. We need to use Newton's second law. It has resultant force downward, the plane, total F equal to ma. Okay, we need to find acceleration using Newton's second law. Okay, so first of all, before we move on, resolve all the forces into x component, y component. So here, the normal force already in y component, friction in x component, mg not yet in x and y component. We need to resolve. So first we resolve resolve the mg. So it has the x component and y component. So x component mg is x component because it is opposite the angle. So it's mg sine 40. For the y component, it is adjacent to angle. So it's mg cos 40. Okay? Because this one use cos because adjacent to angle. Right? The x component is sine because opposite to angle. Okay? When this is 40 degree, this one also 40 degree. Yeah? Now, another thing is about the sign for direction. This is important. Yeah? I want to explain. Sign for direction. When object in equilibrium means no resultant force, total F equal to 0, acceleration 0. We consider the direction like this. Going to the right, positive. To the left, negative. Going up, positive. Going down, negative. As usual. This is usual. But if the object has resultant force, which means that it is not equilibrium, it uses the Newton's second law, total F equal to ma. When not equilibrium, has acceleration, when the object has acceleration. So the sign is when follow acceleration, use positive. When opposite acceleration, use negative. It looks at the acceleration. Follow acceleration, positive. Opposite acceleration, negative. Okay? Good. Now, we must put the sign here signed. If we look at we must do both component, x and y component. If we look closely, only the x component has acceleration. Yeah, the x component has acceleration, but the y component total F is 0. No acceleration. Yeah, because the object didn't jump up and down along the plane. It just accelerate down the plane, isn't it? So acceleration only in x component. Yeah, only the x component has resultant force. The y component has no acceleration, no resultant force. This is equilibrium. This is not equilibrium. Now you need to put the sign. For y component, no acceleration. So we just put going up is positive, going down is negative. This one, like this one. Okay? But for x component, it has acceleration. So follow acceleration is positive. So going down is positive because follow acceleration positive. Yeah, this one. Total F equal to ma. Follow acceleration positive. So follow acceleration positive. Opposite acceleration negative. Yeah, opposite acceleration negative. This one for opposite acceleration negative. All right. Okay, settle that one. Now we move on. First of all, we find the okay, for x component. Okay, for x component, we have what value? We have the mg sine 40 and the friction. Okay, these two forces only. So the mg sine 40 is positive. The friction is negative. Okay, mg sine 40 is positive because follow acceleration. Friction is negative because opposite acceleration. So let us write down. Mg sine 40 positive because follow acceleration. Friction negative because opposite acceleration. Negative friction equal to ma. You see that? Okay. So we got it. We nailed it. Now, what's the formula for friction? Friction is, okay, let us write mg sine 40 minus mu kn. Friction is mu n. Friction is mu n. Oh, here we need to find the normal force. We need to find the normal force. So normal force, you need to do also the y component to get the normal force. So we want to find the normal force. We need to do the y component. So let's do the y component. Y component has no acceleration. So going up positive, going down negative. So for y component, only you have normal force and mg cos 40. Normal force is positive, mg cos 40 is negative. Okay, so normal force is positive. Normal force is positive. Mg cos 40 is negative. Negative mg cos 40. So m is equal to mg cos 40. Alright? Do we have the mass? No, the question didn't give the mass. So we don't have the mass. We leave it like that. We leave it like that. Okay? Because later the mass can be cancelled out. Yeah? What we already got the normal force, so we can substitute the normal force to the x component. Okay? We can substitute there. So just substitute, and we got it. So mg sine 40 minus mu. Mu k already have 0.1. So put 0.1, and then the normal force is mg cos 40. And then put the ma. Do you see that? We can cancel the mass. Even the question didn't give the mass. Never mind, we can cancel the mass. So we no longer need the mass. We no longer need the value of mass. Okay. So from here, we can get the acceleration. We can calculate the acceleration already. So our acceleration will be equal to, so G itself is just substitute with 9.81. Yeah, positive. G itself is just substitute with 9.81. And our acceleration after calculate, we got 5.554 meter per second square. That's the value of acceleration. We got the acceleration, we can get the displacement already. So we can get the displacement because we already have all the value. Okay, we already have the initial velocity is start from 0, final velocity 40 km per hour already changed to meter per second 11.11. Okay, meter per second. And then we already have the acceleration we got just now, 5.554 meter per second square. So we want to find the displacement. So we use a formula VOAS from kinematic of linear motion, chapter 2. So which is v square equal to u square plus 2as. So 11.11 square, and then this one is 0. Okay, 0. And then 2a is 5.554 s. We can get the s. So we calculate, we got 11.11 meter. That's our displacement. Okay. So it's very simple. Okay, that's the displacement will be the length of the plane. Yeah, length of plane. All right. So that's very simple. Hope you enjoyed the video. Let us wait for the coming videos. Bye.